Hello, I'm Isaac Baumgartel. I'm talking about electrostatics as my research project. So basically, electrostatics is based on the law or theory that all atoms, all particles have a charge, and it's caused by like the electrostatic shocks or force or repulsion or attraction is all caused by attraction of these particles with a charge. So what I'm going to demonstrate, because I need a visual aid of some sort, is this balloon has an electrocharge, which I think is negative. I'm not sure. The atoms in this balloon have a negative electrocharge, and according to one of the websites I found, human skin has very high positive electrocharge. So by rubbing these two together, I'm causing them to interact, which causes a high electrostatic charge. And then what this does is allows me to pick up Rice Krispies. You see that? Look, these tiny, because they're very light, so the balloon can pick them up. But you can't really see. So you got that one hanging there. But yeah, so because of the electrostatics, you have an attraction between Rice Krispies and the balloon, because I caused the negative and positive atoms to interact here. So electrostatics is basically all described by Coulomb's law, which is there are particles everywhere, and they are all attracting and repulsing each other at any given time because they all have charges, and over an amount of distance they will attract or repulse each other depending on their charges. So we know that based on magnets, you play with a few magnets, and you can tell that if you flip over the magnets, they won't go together very well. But if you flip one of them over again, they'll stick to each other real quick. And that's kind of what we're getting at here. The idea is negative attracts positive, positive attracts negative. Negative and negative, they don't really attract. And this is all based off of protons and electrons. If the amount of electrons outnumber protons, you'll have a negative charge. The amount of if the amount of protons outnumber the electrons, you have positive charge. So we're going to take, say, positive charge atom over here, negative charge atom over here. They're going to attract. Negative charge atom, they're going to repulse. That's Coulomb's law. They repulse each other over a distance because they're charged the same way. Now, Coulomb's law is a lot like Newton's law of gravitational theory, or Newton's universal law of gravitation. What Newton says is that all items of mass will attract each other. Now, Newton's law is different from Coulomb's law because it only deals with attraction, not repulsion. Also, Newton's law deals with anything of mass. Now, Coulomb's law deals with any ionic substance. So those are the main differences, but they're pretty similar. Just that Newton's law isn't really constricted to just charged particles, and Coulomb's law isn't constricted to just attraction. So that's that part of that. There was one question comes up a lot actually if you type it on Google, is why do we get shocked more in the wintertime than in summer? This doesn't have to do with like different particles being in the air or the fact that like it's wet. Well, it does have the wet factor in it, but in summer, especially here in Indiana, you notice there's a whole lot more humidity in summer. You'll sweat a whole lot more, which given because it's hot. There's a whole lot more humidity in summer than there is in the winter. Now, humidity helps to bleed out electric charges, which gets rid of electrostatics and all that stuff that's going to hurt you if you touch metal. But in the winter, humidity condenses. So like in the summer, you kind of like think of humidity as a gas. It'll all expand. It'll be everywhere. In the winter, however, everything's cold, so it condenses. If you took chemistry, you understand that. The um, one thing that a lot of people will tell you as advice is to always carry around a little metal coin in your pocket, because that way anything that like charges you will just instantly go into that coin, so you don't shock yourself when you touch something metal. What's the other question? Oh, the different methods of charging things. So you already saw my balloon experiment. Now that's the rubbing. So by rubbing, it means I'm forcing electric, negative and positive ions to attract, which causes stuff like this to happen. There are other methods. One method is separation, which is, I think that happens in this too. So when you're rubbing them together, they're all rubbing and interacting and they're all nice and happy. But then when you separate them, there's always some electrons caught in the middle there because these particles are going to want more electrons and these particles want more electrons, or some particles want to lose electrons. There's always some electrons caught in the middle, so I can kind of feel it when I get close. But there's always something caught in the middle, which causes an electric charge. This can be seen when you if you're wearing like a sports shirt or something, and you try to take off a sweater, like a wool sweater usually, then you can like hear the like crackle, snap, crackle, pop of the sweater coming off. Other methods include, I think, induced. And induced is pretty much just taking a positive charge and negative charge and putting them together. And that's going to cause, like magnets, I guess. That's going to cause an attraction, which is electrostatic. The other ones are, you can use certain heating and pressure methods. Those aren't very clear. They're used, I think they're mostly used in like manufacturing. Thanks, Atticus, you just ruined my video. Other method, I don't think there are any other methods to physics electrostatic, like to the electrostatics of stuff. But that's my whole spiel. I don't think there's anything else I learned. Sorry if I disappointed you, Miss Taylor. My sources, I don't know how to MLA cite that in a video. I'll research that and hopefully get that turned in. But I used Yahoo Answers for one of them, and Wikipedia. No, I didn't use Wikipedia. I almost did. I was tempted. But that's electrostatics for you. There's nothing more. By the way, this is really an easy experiment. I learned it on Zoom, that old show. You just kind of like rub this. I thought you used hair, but it turns out human skin is a whole lot more charged than just hair. Weird. Alright, that's my video. Thank you.